Hello students. Topic polynuclear hydrocarbons. The name itself says that poly means many nucleus hydrocarbons. Hydrocarbons means it contains hydrogen and carbon. Okay. Here polynuclear hydrocarbons means it is the class of aromatic hydrocarbons containing multiple aromatic ring. That means it contains more than one benzene ring. Okay. Now again there is and here electrons are delocalized in it. I repeat once again. Poly means many, nuclear means nucleus. It contains more nucleus. Okay. Hydrocarbon means that contains carbon and hydrogen. Polynuclear hydrocarbons means it is the class of aromatic hydrocarbons contains multiple aromatic ring. Okay. And here electrons are delocalized in it. Okay. Now look at here. The name of this compound is diphenyl. Di means two, phenyl means this group is called phenyl group. When it acts as a substituent, then it is called phenyl. Okay. Again one more example, diphenyl methane, or the name of this compound is naphthalene and it is anthracene, and one more example, that is phenanthrene. Okay, phenanthrene. Now look at here. I said it is polynuclear aromatic hydrocarbon. Is it aromatic? Yes, it contains benzene ring. That's why it is aromatic. Is it polynuclear? Yes, it contains more than one benzene ring. That's why it is polynuclear hydrocarbon. Okay. Now look at here. Here it contains 3. Here it is 2. Here it is 2. Again here it is 2. Now again there is a 2 types, isolated rings and fused ring. Now look at here. It is the types of polynuclear hydrocarbon. The name itself says that isolated rings. Isolated means separated. Okay. Now look at here. Diphenyl. Is it isolated ring? Yes. There is a one bond that separates two benzene ring. Okay. Next example, diphenyl methane. Diphenyl and this is methane group. Okay. Is it isolated? Yes, it is isolated. Why? Here two rings are separated by this methyl group. Okay. Next one is a fused rings. What is fused ring? Here two benzene rings are two or more than two benzene rings are fused together. Okay. The name of, now look at here. Here two benzene rings are fused together. Here three benzene rings are fused together. Again phenanthrene means here also three benzene rings are fused together. So that's why it is called fused ring. The name of this compound is naphthalene. This one is anthracene. Okay. Then one more is phenanthrene. Okay. There are so many examples. We are going to discuss only few fused rings. Okay. In that first one is naphthalene. What is naphthalene? Here two benzene rings are joined together. So that's why it is called naphthalene. Now look at here. Again it is the one of the largest constituent of coal tar. Okay. It is a simple fused ring system. That means here only two benzene rings are fused together. Okay. Again it is a colorless crystalline solid. It melts at 800 degrees Celsius. Okay. And it undergoes sublimation. Sublimation means on heating it becomes it converted into vapor form. Okay. And it is insoluble in water and soluble in organic solvent. Now look at here. This is the naphthalene. Here two benzene rings are fused together. The numbering starts from here. Look at here. 1, 2, 3, 4, then 5, 6, 7, 8. And here 9 and it is 10. Okay, it is the numbering of polynuclear hydrocarbons. Okay, now first position it is also called alpha, it is beta, it is gamma, delta and so on. Okay, that's why first position is called alpha position, second position is called beta position. Now look at here, what is the name of this substituent? So this is the first position, again second position, third position, fourth position, so on. Okay, so that's what's the name of this compound. 1-naphthol. It is naphthalene. It is an alcohol group, so that's why 1-naphthol, or it is called alpha naphthol. Okay. Next, second one. 1, 2, 3, again 4, 5, 6, 7. Sorry, 1, 2. This is 3, 4, 5, 6, 7, 8. 9, 10. Again the name of this compound is 2-naphthol or beta-naphthol. beta naphthol. Next example, again numbering starts in same direction. So what's the name of this compound? Yes, now look at here. There is a two substituent, right? One is a methyl group, one more is nitro group. The numbering starts from which group? Methyl and nitro. In alphabetic order, which one comes first? Methyl group comes first. So that's why this is the wrong method of numbering. Now numbering starts from here. 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10. What is the name of this compound? 1 methyl, 1 methyl, 4 nitro, naphthalene. Okay. Next example, again here two substituent is present, one is presented. Numbering starts from the carbon that contains substituent, right? So that's why 1, 2, 3, 4, 5, 6, 7, 8. What's the name of this compound? 1, 8. How many bromine atoms are there? 2. So 1, 8 dibromonaphthalene. Okay, so this is the example for some naphthalene derivatives. Okay, 1 naphthol, 2 naphthol, and 1 methyl, 4 nitronaphthalene, and 1, 8 dibromonaphthalene. Okay. Now let us discuss the preparation of this naphthalene. Okay. This is the very familiar method. It is called Haworth synthesis. Okay, it is very important for 5 marks. Haworth synthesis. What happens here? Benzene that is treated with, what is the name of this compound? It is called succinic anhydride. Why it is succinic anhydride? Now look at here. Right here, C double bond O, CH2, CH2, C double bond O, OH. It is called succinic acid. Okay, succinic acid. So what is this? This is anhydride. What is the general formula of anhydride? R C double bond O, O C double bond O, R is called anhydride. Is it right? R C double bond O, O C double bond O, R. It is cyclic anhydride. Okay. Here, what is this? This is succinic anhydride. This is succinic acid. By the loss of water molecule, OH from here, H from here, what you are getting? C double bond O, CH2. Look at here, C double bond O, CH2, CH2, C double bond O. There is oxygen that links to this carbon. Okay, hence it gives succinic anhydride. Okay. Now this reaction is what is this? Anhydrous aluminum chloride. So this is very familiar reaction. Benzene that react with anhydride in the presence of anhydrous aluminum chloride. So this is called Friedel-Crafts reaction, right? Now look at the catalyst, anhydrous aluminum chloride. So that's why there is a benzene. It undergo electrophilic substitution reaction. It is the very familiar reaction, Friedel-Crafts acylation reaction. Okay, here it undergo Friedel-Crafts acylation reaction. What happens in Friedel-Crafts acylation reaction? See, this is benzene, this is succinic anhydride. You know that benzene is electron rich, hence, and here carbonyl group is present. Always carbonyl carbon. Here carbon that possesses partial positive charge, oxygen that is highly electronegative, that's why it retains partial negative charge. Okay, so that's why now this benzene thing is electron rich. So that's why it attacks the positive means electron deficient. What is that? Carbonyl carbon. Then number of bond around this carbon 1, 2, 3, 4, and one more new bond is formed, right? 5. It is impossible. So that's why this single bond that migrates towards oxygen. Okay. Now oxygen carrying negative charge. So I will write here once again. What is there? There is a benzene ring. Okay, this is the benzene ring. Now there is a succinic anhydride, C double bond O, CH2, CH2, then C double bond O, right? Okay. this bond attack electron deficient carbonyl carbon. Now number of bond around this carbon is 1, 2, 3, 4, 5. It is not possible. Then it shift here. Okay, then what you are getting here, benzene ring. Now this bond migrates here, then that attacks here, right? So that's why now this bond that directly links to the carbonyl carbon, C double bond O, then there is a CH2 group, then there is a one more CH2 group, then there is a C double bond O group, then oxygen, there is a oxygen. What is the charge on oxygen? That is a negative. Okay, now what is the charge on this particular carbon? Positive. Why it is positive? Actually here what happens, this bond migrates here, that's why here positive, here negative. Negative means electron rich, hence it attacks the carbonyl carbon. Okay, then now look at here, there is a one hydrogen, right? Are you agree? Why? Because each carbon is bonded to 4 hydrogen, right? But here number of bonds 1, 2, 3. Sorry, 1, 2, 3 bond. So that means each carbon that contains one hydrogen, right? So in bond line representation we are not going to represent any hydrogen, but here there is a one hydrogen, right? Then what happens? This oxygen negative charge that pulls this hydrogen. Okay, then O minus become OH. This bond migrates here in order to neutralize this positive charge. Okay, then what you are getting? See, double bond, here new bond is formed, right? Double bond, then C double bond O, CH2, then C double bond O, then here OH. Okay, this is the product of Friedel-Crafts acylation reaction explanation given here. Okay, what happens here? Benzene react with succinic anhydride in the presence of anhydrous aluminum chloride. It gives product 3. What is the name of this product? Now numbering starts from here, 1, 2, 3. Okay, what is the name of this compound? This group is called benzoyl group. Okay, benzoyl group. Now 1, 2, 3. In third position, what is there? There is a benzoyl group. So the name of this compound is 3-benzoyl. What is this? Number of carbon is 3 means propane, right? There is a functional group, carboxylic acid. So oic acid. The name of this compound is 3-benzoyl propionic acid. Okay, followed by then third reactant that gives fourth product. Okay, what is the difference between third and fourth? Look at here, there is a benzene ring. Yes, there is a C double bond O group, but here CH2 group, then CH2, 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 C double bond O, OH, same. What is the changes? C double bond O is converted into CH2. What is this reaction? Oxygen, carbonyl group is converted into hydrogen. There is a addition of hydrogen in the product, right? Or removal of oxygen. This is called reduction reaction, right? What is reduction reaction? I write here, there is a C double bond O, right? That is converted into CH2. What is this? Removal of oxygen or addition of hydrogen. It is called reduction reaction. What happens in the reduction reaction? Yes, I said removal of oxygen or addition of hydrogen. This reaction is called, this is a reduction reaction. Okay, it is given by one scientist called Clemmensen reduction. Clemmensen reduction. Okay, here zinc amalgam in the presence of concentrated HCl. The reaction is carried out in the presence of this reagent. Okay, so that's why this reaction is called Clemmensen reaction, Clemmensen reduction. The third one is converted into fourth one by Clemmensen reduction. What is Clemmensen reduction? Removal of oxygen or addition of hydrogen by the reagent zinc, amalgam and HCl. Is it clear? There is not just remove oxygen, remove double bond, then add 2 hydrogen. Okay. Followed by treatment with concentrated sulfuric acid. What you are getting? The name of this product is tetralone. Okay. What is the name of this product? Tell me. Numbering starts from here. 1. Because carbon that possesses functional group, right? 2, 3, 4. Tell me the name of this compound. In fourth carbon that is attached to benzene ring. Here benzene ring that act as a substituent. When benzene ring that act as a substituent, then it is called phenyl group. Okay. So that's why the name of this compound 4-phenyl. Then what is this? Number of carbon is 4. Butanoic butane, and then in the first position there is a carboxylic acid functional group, right? So the name of this compound is 4-phenyl butanoic acid. Okay. Now fourth one is converted into fifth one. How? By the treatment of treatment with concentrated sulfuric acid. Okay. What happens here? Look at here, CH2, SCH2. Right. Here is one carbon, 2 hydrogen is present, right? Bond length representation. Again there is a CH2, C double bond O, C double bond O. But here OH is present, here not, right? Now look at here, there is a hydrogen. Are you agree? Because carbon is tetravalent in nature. Each carbon that possesses one hydrogen, right? Because tetravalent nature. Now there is a loss of what? Water molecule. Okay. Now there is a loss of water molecule. Then what you are getting? C double bond O. Now that is directly linked to the benzene ring, right? C double bond O. Then remaining all are same. Okay. Is it clear? There is a loss of water molecule. Remove hydrogen from here, OH from here. Hence it gives the product tetralone. Now it is undergo what is our intention to synthesize naphthalene. Okay, naphthalene means 2 benzene rings are fused together. Now there is a O, right? Now how to remove this carbonyl group? What you have to get? Here 2 hydrogen, right? What is next? How to convert oxygen into hydrogen, or how to convert carbonyl group into hydrogen? Yes, again it is a Clemmensen reduction. What is Clemmensen reduction? Removal of oxygen, addition of hydrogen. Again it is carried out in the presence of reagent zinc, amalgam and HCl. Then this oxygen that is converted into hydrogen. Because carbon forms 4 bonds, right? 1, 2, 3. Now this double bond is converted into single bond and addition of 2 hydrogen, followed by heating with one reagent, selenium. Then it forms naphthalene. Okay, is it clear? Now how sixth? What's the name of this sixth compound? You know that this is naphthalene, right? Now what is the difference here? Here 2 hydrogen is present, here bond is present, here also bond is present, right? Now the name of this compound is actually, here 2 hydrogen is present, right? So that's why the name of this compound is 1, 2, 3, 4. 4 means tetra. What is this? Hydrogen. Tetrahydronaphthalene. Okay. Followed by heating in the presence of selenium. What we are getting? There is a loss of hydrogen. How? Now look at here. This bond migrates here. Okay. Then this bond migrates here. Then what you are getting? There is a double bond, and there is a loss of 2 hydrogen. Here new double bond is formed. Here also new double bond is formed. What is this? Naphthalene. Okay. So this is very important, very important for 5 marks. So it is given by the scientist Haworth. So that's why it is called Haworth synthesis. Haworth synthesis that involves Friedel-Crafts acylation, followed by Clemmensen reduction, followed by treatment with the concentrated sulfuric acid, that means acidification reaction, again Clemmensen reduction, finally heating in the presence of selenium. Okay, Write the reaction. First, benzene is treated with succinic anhydride. It undergoes Friedel-Crafts acylation in the presence of anhydrous aluminum chloride, and it gives one product. Third product, followed by Clemmensen reduction, it gives fourth product, followed by dehydration. Dehydration means D means removal of, hydration means water molecule, then it gives tetralone, followed by Clemmensen reduction, again it gives tetrahydronaphthalene, followed by heating, again there is a removal of hydrogen, dehydrogenation, it is dehydration, here dehydrogenation, then we are getting the naphthalene. Okay, it is very important. And second method of preparation, first one is very important. Second method of preparation is from 4-phenyl but3-enoic acid. Okay, it is also called fitting reaction. Okay, what is this fitting reaction? What happens here? What's the name of the reactant? 4-phenyl but3-enoic acid. Okay, first numbering starts from the functional group 1, 2, 3, 4. Okay, what is this? Carboxylic acid. Now what is the fourth position? There is a phenyl, right? 4-phenyl and number of carbon is 4, so that's why but. And third position there is a double bond 3-ene, right? 3-ene. Now functional group is carboxylic acid, hence oic acid. Remove this O. Okay, so this is the name of the reactant. First one, treatment with concentrated sulfuric acid means dehydration. Then what you are getting? This product. Okay, here double bond is present. Next this. Then now what's the name of this compound? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this? First position OH group 1-naphthol or alpha-naphthol. Okay, 1-naphthol or alpha-naphthol. How this product is formed? Now look at here. There is a one hydrogen, 1 or 2, Cl2 hydrogen, because carbon forms 4 bond. Okay, next step, this bond migrates here. Okay, single bond become double bond. Then here number of bond around this carbon 1, 2, 3, 4, 5. Is it possible? No. Why? Carbon is tetravalent. Then O become O minus. It is O minus. Now there is a one hydrogen OH. Okay. Double bond OH. Followed by reduction in the treatment with zinc dust. We are getting naphthalene. Okay. Next last reaction. So that is from 4-phenyl butene. 1, 2, 3, 4, 4-phenyl. Okay, it is a benzene ring. 4-phenyl but 1, 2, 3, 4 carbon. EN means there is a double bond that is treated with calcium oxide in the presence of red hot calcium oxide, that gives naphthalene, followed by what is that? There is a removal of 2 hydrogen. 1, 2, 3, 4. 4 carbon is present. 1, 2, 3, 4. Then there is a double bond. Okay, here also double bond. There is no double bond. Here 2 hydrogen is removed from this position. Then we are getting naphthalene. Okay, so this is the method of synthesis of naphthalene. First method is very important for the exam.